The leafcutter ant family is divided into two genus, the Acromyrix and the Atta ants, which are both native to countries like Costa Rica, El Salvador, Guatemala, Honduras, Mexico, and Panama. So what makes them different and battle between each other? This is a sea urchin tooth. Random? Maybe not. Researchers found out there might be more in common between acromyrix ants and sea urchins than we thought, the commonality lying in the armor of the acromyrix ants. Uniquely, acromyrix ants have a specialized set of armor that creates a white layer that we see over their exoskeleton, which is made up of calcite. This calcite armor is formed through the process of calcium carbonate biomineralization at the cuticle and epicuticle layers. What makes the acromyrix armor unique is the unusually high levels of magnesium found in the calcite. Wait, before we get ahead of ourselves, what is calcite? Calcium carbonate comes in three crystal forms. Calcite being the trigonal crystal, agronite, the 𝕤𝕤𝕚𝕚, and the vaterite hexagonal crystals. Calcite is the most stable crystal form of calcium carbonate and is most commonly found in seawater organisms. Crystal users are probably familiar with calcite crystals' calming properties. Calcite is also found in limestone, but the process of calcite formation has been adopted by the outer layer of organisms including mollusks, sea urchin spines, brittle stars, and chitons. Okay, so there's a high level of magnesium. The question is, what is the function of this armor? Through several experimental tests, the researchers concluded the acromyrix ants' mineral armor made their exoskeleton 7 times harder than if they were not to have armor. They also noted that this mineral armor only started to develop when the acromyrix ant hits maturity, which is around 6 to 8 days after the pupae became a callow. Back to the battle. The researchers wanted to put both leafcutter ants in the ring. Using 2 experimental groups, the researchers have removed the mineral calcite armor layer off of group 1, composed of 3 ants, and then the second experimental group was composed of 3 mineral-present ants who had the armor layer. The battle begins. Each acromyrix experimental group was set to fight against one Atta ant soldier. The results were just as predicted. The acromyrix ant with no mineral armor had a higher fatality rate and more missing body pieces, whereas the acromyrix ant with armor were able to kill the Atta ant and win the battle. So there, we know that the magnesium calcite layer has a protective role to fight off of other ant colonies. But is this mineral layer just armor? Acromyrix ants have a unique mutual relationship with fungus. Fungus provides the ants food and the ants work to protect and keep the fungus alive. Beautiful relationship, right? But with fungus comes bacteria. This biomineral armor layer helps protect the acromyrix ants from the spread of dangerous fungi pathogens. Evident as acromyrix ants with no armor started dying in large numbers on day 3 of infection, whereas armored acromyrix ants survived longer against fungi pathogen infection. So this not-so-simple high magnesium calcite mineral armor protects acromyrix leafcutter ants from the attacks of neighboring enemy ant colonies and protects them from the smallest fungi bacteria. This opens doors in the research of insects. Who else possesses this amazing magnesium calcite armor? Maybe we should start making some for ourselves. Far ahead? Who knows, but for now let's leave it to the ants.